Assalamualaikum warahmatullahi wabarakatuh. My name is Fidos bin Azman. Today I want to present about non-Newtonian rock bump. Let's go for the first section in this presentation. Is background. Okay, what is the speed bump? Speed bump is a safety device that is used to slow down the traffic, act as a non-supervised police traffic. Okay, non-Newtonian fluid bump. What is non-Newtonian? Non-Newtonian is especially a fluid made from a cornstarch and water. This fluid is not obey to Newton's law because the viscosity of the fluid can change directly to the force. Let's say the bigger amount of force, the harder become the fluid, or the viscosity of the fluid can increase. And when the speed of force is a little amount, the fluid can be so soft and the viscosity is so low. Okay, let's go to the next part. Okay, now we go to the major part of our assignment to complete or to develop our product is problem statement. We must to do some researches to our problem and we can do a better product for solve the problem. What is the problem? There are so much complication toward the vehicle during the impact of the speed bump is our main problem. What is complication toward the vehicle when the vehicle is through the speed bump? First, the damage to the shock absorber, the air pollution increased due to speed bump, low visibility of the speed bump, and the time delay which cause poor fuel consumption. Okay, there's four major problem statement and we must solve it. Okay, now we go to our mission and vision. Our mission is to address problem with traditional speed breaker, reduce damage, and prevent accident. To build a long-lasting environmentally beneficial alternative to concept speed breaker. And our vision is aim to develop manufacturing of road bump while keeping original purpose of the road bump. And our long-term vision is this project will cover all road user in Malaysia, including Peninsula Malaysia, non-Peninsula, the EAS, veteran, and more. But our mission and our vision is must be to the our team is environmentally sustainability. Okay, next we go to literature review. From literature review, we can get a three pattern from three different person. The first person is Graham L. Barber, Scott Broughton, and Graham Hicks. Okay, let's go to the first pattern from Graham L. Barber. From that pattern, the degree of jar impacted to the vehicle depend on its speed. Elongated steel chamber with the fluid inside is the housing of the fluid. Flexible elongated housing secure by spike two flanges into the rod head. This is a good pattern for our team to make to do a concept and develop our product. But we must see the second concept from Scott Broughton. This the spec bump is made of plastic to keep weight low while maintaining durability. That a good idea to our team to develop a concept is not using a tar, is a not using a steel or tar, but we can use a plastic too. Let's go to the last person for this literature review is Graham Hicks. Graham Hicks said his patent have his product have a valve inside wall for deflection and reinflation. Graham Hicks made this rod bump because the current speed control system are costly, disruptive, and confusing. That's right. And the system and repair to the rod are never ending. Okay, from this three literature review, we get all information for the road bump. To develop the road bump is first the degree, the material of the road bump, the housing of road bump, and the system of the road bump. Okay, let's go for our concept, our custom minutes. How we can get custom minutes? First, we do a survey from a Google form in our first assignment. And from the Google form, we can do the house of quality. Let's check it out. The first part in house of quality is the rooftop. The rooftop is the part with a correlation between the engineering requirements such as strength, shape, material, and outer shear pressure, fluid pressure. The plus sign in the correlation is the good correlation. Is no sign in correlation is that mean is no correlation, or negative is negative correlation. Let's say when we want to the strength, we must have the good material. If we want to lose the weight, we have to lose the shape or the material. And we get the middle part, right hand side and left hand side. First thing first, I want to say about, and first thing first, I want to say about right hand side. What we have in right hand side, we have the customer needs. Where we get the customer need, we get from Google survey. We get eight for eight customer needs. Is first portable, easy installation, high durability, low core maintenance, long lasting, height of right bump, safety road element, sensitive to the speed bump, and the low core maintenance. Okay. After that, we go to the middle part of the house of quality. And engineering's requirement. From the center grid, the dot with the black color indicate a strong relationship of weight of 9, and a circle with no color inside is a medium relationship with a weight 3, and a triangle shape is a weak relationship with a weight of 1. The weight is very important to our to, to, con, to proceed to the bottom of the house of quality. In the bottom of the house of quality, we get the measurement unit, technical important rating, relative weight, and competitor mark. For the technical importance weight is a sum of the weight from the correlation in middle part of the house of quality. Okay, after that we can compare to our product and our competitor. Okay, now let's go for next part. We get the concept sketching. What a concept sketching? Why we can do concept sketching? Okay, we make the concept sketching based on the pattern, based on the customer needs, money, time, and the important thing is environmental sustainability. Let's go. We have a three concept with three different material, three different design, and three different size. Yeah, let's go for concept screening. Concept screening. What we get in concept screening? We get installation criteria in left hand side, concept B, concept C, concept D. What? Wait, we just have a three concept, right? But in the for the concept D is for references. References is from our competitor, Nova. In selection criteria, we have choice from the customer needs based on time, cost, and environmental sustainability. Let's go for the plus sign and negative sign or zero. Okay, the plus sign in this concept screening is shown as the better than, which means in concept A for portable we can see have a plus sign, but in concept D is a zero. That means a concept A is better than concept D. But also we have a 0 as a same as or negative as a worse than. For complete this concept scoring, we have a several steps. Step 1 is prepare the selection metric. Step 2, write the concept, which means we put the plus sign, negative sign, and 0. And rank the concept, which we must sum of the plus sum of plus sign plus, minus of sum of negative sign. And we can combine and improve on the concept and select one or more concept to develop, or we go to the next our next methodology step is concept scoring. As we can see in our concept screening, concept A get the sum of plus sign is 3 and sum of negative sign is 3, but sum of 0 and total sum of that sign is 1. And net score for that concept is 3. Net score for concept B is negative 2. Concept C have a net score negative 3. And concept D have 2 net score. From that, we can ranking this concept. Concept A get the first rank. Concept B get the second. And concept D get the third rank. Okay. Concept C is especially get the last number is 4. Fourth in rank. Okay. Our team had decided to continue the concept A, concept B, and concept C to develop this product. Okay, let's go for the next concept scoring. At this point, our team reconsider the real significance of the selection criteria and concentrated on more accurate comparison about each criteria or each concept. The way total rating determine the ideal score, there are 3 concepts in the selection that will be scored to determine which concept the road bump is suited or better. Okay, we can see from the concept scoring table, we get a selection criteria. Yeah, we get from a customer needs, also based on our time, cost, and also sustainability environment, environmentally sustainability. Okay, we can see the portable had a 10% of weight, also high durability, also for loss cost maintenance. But we can see there's a high weight of sensitivity of the speed vehicle is 25. This means that sensitivity of the speed vehicle is the major component in our scoring table for score the concept. Okay, let's go. How we make this, how we do this concept scoring. We have a several steps. The first step is prepare the selection metric. Yeah, we have to prepare the selection metric. Number 2 is rate the concept. As in the screening stage, this is generally easiest for our team to focus in its discussion by rating all of the components which respect to one criterion at a time because of the need of additional resolution to distinguish among competing components. A final scale in now use, we use a scale from 1 to 5. We can see at the concept A, for portable, we get a rating 5, high durability. Also for low cost, also for long lasting, and also safety road element, we get 5. But the rating for concept A for the sensitivity of the speed vehicle is 4. Also for a low installation cost. Okay, from that rating, we can get the weight score, or we can rank the concept from the subtotal of the concept. For this concept scoring, total score of the concept A will 2, 2.42, concept B is 1.98, and concept D were 1.98, where the concept B and concept D have a same total score. Have a, sorry, have a same total score, which is the concept A have a first rank in this concept scoring, which does mean this concept A is our concept to develop this product. So from that, our team had decided to use concept A to make this design scoring. For the designing, our team had made this design based on the real size of the rock bump in Malaysia. What we can see for the designing, this is our design. Okay, before I talk furthermore, let's see the simulation of this rock bump. Okay, for this rock bump, we can see we have an outer shell, is a yellow color, and base plate, base, nut, and bow. Okay, we can see from piece of material, we can see to the parts of this non-Newtonian fluid, which mean which is the first part is base plate, second part is outer shell, third part is fluid packaging, and number 4 is bolt, number 5 is nut, and number 6 is base. Okay, for piece of material, if as build for bit of material, we can see we have a quantity, description, material, and price per unit. For the base plate, we get for the base plate, the function of the base plate is to hold the outer shell and fluid packaging with bolt and nut. And the material of this base plate is fiber reinforced plastic. And then the second part is outer shell is to protect the fluid packaging by using the PVC coated polyester fabric. After that, we get a fluid shell. For the bolt and nut, we have used a carbon steel to tighten connection between the base plate, base, and the outer shell. For the base plate, for the base, is made from fiber reinforced plastic to protect all of the components. Design for environment were the last part in this presentation. But what is design for environment? Is a method to minimize and eliminate environmental impact of a product over life cycle. Effective DFE practice maintains or improve product quality and cost while reducing environmental impact. DFE expand the traditional manufacturer focus on the production and distribution on its product to a closed loop life cycle. Product life cycle. What we get the major component in product life cycle is material, production, distribution, use, and disposal. Okay, let's go for the main concept of the DFE. The first concept is design for environmental processing and manufacturing. This ensures that raw material extraction like mining, drilling, processing usable material, metal melting, and another as also manufacturing are done using material and process which are not dangerous to the environment of the employee working on site processes. Okay, next part will be the design for environmental packaging. This ensures that the material used in packaging are environmentally friendly, which can be achieved through the reuse of shipping products, elimination of unnecessary paper and packaging product, efficient use of material and space. Next will be a design for disposal and reuse. The end of life of a product is very important because some products emit dangerous chemical into the ground, and water after they are disposed in a landfill. Planning for the reuse and refurbishing of a product will change the type material that would be used, how they could later be disassembled and reused, and the environmental impact such material have. And lastly will be a design for energy efficiency. The design of a product to reduce overall energy consumption throughout the product life, like electricity, maybe the human energy, human work energy. Okay. Okay. After that, we can also set for an example of design for environmental guideline. The first thing in DFE guideline, we do not combine material incompatible in recycling, label all components of the material, enable easy disassembly, use no surface treatment, eliminate packaging, and reduce weight of size for shipping. Yeah. Next part is step in LCA analysis. What is LCA? LCA is life cycle assessment. In life cycle assessment, we get the prepare, process, design option, identify life cycle, identify all material and energy source, identify output and waste streams, quantity impact of each material, and aggregate impact into categories for comparison. For this step in FCA, our team have used this step for our product is for our product. For develop our product, our team have focused in this step in LCA analysis to make sure the environment to, to achieve the sustainable of environment. Okay. In conclusion, we have developed a solution and adapt the rod bump while changing the material without compromising its safety. This indicates that while we continue to refine the process for making rod